Welcome to Brain Vision.
Problem 776, we have a particle that is moving along the x-axis with a single conservative force parallel to the x-axis. We're given the force that on the corresponding to the potential energy function, which is graphed here. It's a very poor graph, but you can look in the text for the one that looks better. So particles released from rest at point A, and we're asked some questions about it. What is the direction of the force on the particle when it's at point A? So one of the key equations we're going to need to remember is we have our force is equal to negative the derivative with respect to x of the potential energy function. So what this means is that the force, if we first find the derivative of the potential energy function, we flip the sign, we get the force. So derivative of the potential energy function at point A, the slope is negative, it's going down. So negative times that negative slope is going to give us positive, so we have a positive force there. So what is the direction of the force? It's in a positive x direction, or to the right. At problem B, at point B, let's see, the slope is positive, so times the negative, it's going to be a negative x. Direction for the force, which is to the left. C, what value of x is kinetic energy of the particle a maximum? So this is an an energy conservation problem at this point. So here is a graph of the potential energy function. So if we have a conservative force acting on it, we're going to have conservation of energy, which means that if we start with this amount of energy up here, and this plus the potential energy, this line plus potential energy, what's left over, meaning this distance between here and here, is all going to be kinetic energy, which means that where we have the greatest difference between this dashed line here and the base, so one of the troughs, is going to be the greatest amount of kinetic energy. So that's going to be right here at the bottom. So that's going to be somewhere around 0.8. Okay, so D, what is the force on the particle when it's at point C? So point C, that's the peak. So that means that we need to, again, go here. So what's the derivative of something that is at the peak of a hill? That's going to be 0 because the slope is 0 there. So that means we have force equal to 0. So we can write that down. F equals 0. E, what is the largest value of x reached by a particle during its motion? So if we have conservation of energy all throughout here, and point C, with this point C just below that, that means that we can reach all the points on this curve until we get to some point above this line, because then we would violate conservation of energy, because we move past the amount of energy we have, essentially, if we go up past here. So the furthest point of x that we can reach is where that point is, because we can't go above it because we don't have enough energy. So that's somewhere between 2 and 2.5. So that I'll just write down 2.3. F, what value or values of x correspond to points of stable equilibrium? So stable equilibrium means that we have forces on both sides of a point such that if the particle moves left, it will be forced back. If the particle moves right, it will be forced back. So what does that mean here? That means here that we have a positive force, which means that we have a negative slope, and we have on the left side, and for the right side, we have a negative force, which means we have positive slope on the right hand side. So points where that occurs is right here and right here. So that would be at the troughs of the potential energy function. And then G, of unstable equilibrium. Okay, so unstable equilibrium is when we are at a point and then with the forces on both sides. So if you're standing on either side of that point, you'd be forced out, away. And if you're standing here, you'd be forced away. So that corresponds to a positive slope on the left-hand side and a negative slope on the right-hand side, which means that you're going to have a peak right there. It's corresponding to a trough for the first case that we had. Okay, so what's that? That's at point C, and that corresponds to and F corresponds to those two troughs right there.